application of adding and subtracting polynomials, and we're going to see that when it comes to shape. So a little bit of geometry that you guys probably remember from middle school. So first thing we're going to talk about is perimeter. So perimeter, remember, that is the outside of all shapes. And so perimeter utilizes addition. So the addition of polynomials. Now, what's nice about perimeter is the formula technically for perimeter is the same for any shape. And all it is that we are going to add, oops, not all, add all sides together. So add all sides together. So easiest example right here is a rectangle. All three sides are labeled, so we just need to add them all together. So the first thing I'm going to do is write it as one large line. So I have x squared plus 6 as one of them, sorry, negative x squared plus 6. I'm going to add that to 4x minus 3y, and then I'm going to add that to 2x squared plus y minus 3. So because it's addition, I don't have any distribution of negative signs or anything like that, so I'm just going to put this into standard form. So the largest exponent is the squared, so negative x squared plus 2x squared plus 4x minus 3y plus y plus 6 minus 3. So it is in standard form, and I can see that like terms are next to each other. So one thing I want to point out is this is an x to the first. These are y's to the first. You can only combine when it's the same variable, so that x is not going to combine with these. And then my constants at the end. So negative 1 plus 2 is a positive 1x squared. Positive 4x is going to come down. Negative 3 plus 1 is going to be negative 2y. 6 minus 3 is 3. And so this polynomial right here represents the perimeter, the adding of all sides of this triangle. Now, where people can sometimes get confused is when all of the sides are not labeled. So for example, in this rectangle, we see that this side is not labeled and neither is this one. But what we have to remember is that opposite sides of rectangles are congruent. So that's what this means. The double line means that these two are the same. The single line means those are the same. So if you need to, you can pencil in, if that helps you visually. This is 9z minus 12. So there's 4 sides, so we're going to have 4 things we add together. So I have 4z plus 7 added to another 4z plus 7 added to 9z minus 12 added to 9z minus 12. It's a little bit longer of a one. So I'm going to put into standard form, so all of my z's are going to go out in front. So 4z plus 4z plus 9z plus 9z plus 7 plus 7 minus 12 minus 12. So a lot. These are all like terms here, and these are all like terms here. So I need to add them together. So 4 and 4 makes 8. So if you need to, this is 8. 9 and 9 is 18. So together, 8 and 18, that's going to make a 36z. You can just do this in your calculator if you need to. There's no shame in that. And just adding all 4 of those together. So 7 and 7 is 14. Negative 12 and negative 12 is minus 24. So 14 minus 24, that's going to be a negative 10 or minus 10. So combining all sides, 4 sides. Now, what we're going to see here is that this is something that has the same sides for every single side. So this is why this is labeled m squared plus 5, because all the sides are m squared plus 5. So we have a 1, 2, 3, 4, and 5. So I'm going to show you a little trick. Instead of writing out m squared plus 5 times, hence that word times, right? We have 5 times the sides. Since they're all the same, we can take m squared plus 5 and times it by 5 because there's 5 of them. So this gives me 5m squared plus 25. Now, if that kind of confused you and you get to a quiz and you literally just add this 5 times, you will end up with the same exact answer. But if it's all the same, you can use however many they are with multiplication. So, same thing here. You have 3a plus b, 1, 2, 3 times. So go ahead and apply that same trick. I want you guys to pause the video, try that trick on your own where you have it 5 times. Okay, so here we have it 3 times, which means I'm going to have 3 times the 3a plus b. And so then I just distribute, I get 9a plus 3b. Pretty simple. Here, though, we do not have the same scenario, right? This is 4 different sides. Now, one thing you'll notice is this side is not labeled. So this side and this side are the same. So this is x squared minus 1. So we are going to have to add all these sides together by hand. So I'll start at the top. We have a 4x plus x squared minus 1 plus 3x squared plus 5x plus 4 plus an x squared minus 1. What I want you guys to do is pause the video now. I've helped you set it up. I want you guys to add this by yourself and then check with your answers. Okay, putting into standard form, I have x squared, positive 3x squared, positive x squared, a 4x, 5x, negative 1, positive 4, negative 1. So these are like terms, these are like terms, these are like terms. So adding their coefficients, 1 plus 3 plus 1, that's 5, so 5x squared. 4 plus 5 is 9, so 9x. Negative 1 plus 4 is 3. 3 minus 1 is 2. So save this one here. We're going to do this one in class together. And I want to talk about this one. So this is a little word problem example that I'll help you guys out with. So Andrew wants to put up new fencing around his backyard. The backyard is in the shape of a rectangle. Okay. He knows that the length is 4 feet less than the width. So I'm going to go ahead and label these for you. The width, we're going to use W, and the length is W minus 4. So what we know, opposite sides are congruent. So this is W minus 4. So adding all the sides perimeter, go ahead and try this one on your own. So pause it here, try setting it all up on your own and solving, and then check with the video. Okay, W plus W minus 4 plus another W plus W minus 4, right? All 4 sides. So we have W plus W plus W and plus W, a minus 4 and a minus 4. All of these are like terms, then these are. So 1, 2, 3, 4, we have 4W minus 8. And we're going to leave this one and number 3 for class. Now, area, second page is area. Area utilizes multiplication. So this one doesn't take up as much space when we start the problem because the perimeter, kind of when we added all the sides, we got really large problems, but it is multiplication, which does require a little bit more work. So one thing to remember is area of a square or a rectangle is length times width. So that's where the multiplication comes into play. Area of a triangle is 1/2 length times, and I'm going to put height, not width. Height. So height is the highest part of a rectangle, okay? So for this one, right, this would be length, this would be width, and all I'm going to do is multiply them together, right? So length and width, this is a 2 by 2, so what we can do is just draw a box for box method, right? Length times width. This first one is going to be 4z and 7, 9z, negative 12. Now, if that kind of confused you, me pulling them over, remember, this is just multiplication, so it's 4z plus 7 times 9z minus 12. So you can kind of see how it looks like the problems we've been doing. Label the sides. This is going to be 36z squared, negative 48z, 63z, negative 84. So I pull it out into standard form. I have 36z squared plus 63z minus 48z minus 84. So we want to look for like terms. It doesn't happen every time, but it does happen. And so we're going to combine by adding the coefficients, right? So 63 minus 48 is going to give us 15. So this becomes 15z. So we have minus 84, 36z to the second. That was positive 15. So that's the area. This represents the area. Now, this one here is a rectangle. So remember, anything with a rectangle, we're using the height, not the length. So if you look, height is going to be in the middle, that vertical point. So same thing, length times width, but we have this extra part at the beginning, the 1/2. But we're going to save that for the end. But I'm going to set this up for you. 1/2 length times width. So what we're going to do first is we're just going to ignore the 1/2. We'll deal with it at the end. I'm going to set up my box method, right? 2 by 2. So 3a and a 2, 4a and a 5. And multiply. So 12a squared, 15a, 8a, 10. So I have 12a squared plus 15a plus 8a plus 10. This is going to combine. So I have 12a squared plus 15 plus 8 is 23a plus 10. Now, here's what we can't forget. This is where people make mistakes. We have to 1/2, right? Multiply by 1/2. So now this is kind of like a distribution problem. So we're going to distribute that times 1/2. So you can just do that in your calculator. This is the fraction button right here, the n over d. So if you look, I can do 1, arrow down, 2, and then arrow over. So 1/2 of 12. That's going to give me 6a to the second. And I'm just going to do that for every one. 1/2 of 23. So this is going to give me a fraction. So what you can do is press this arrow button, and it's going to give me the decimal. So plus 11.5a. And then 1/2 of 10, that would give me 5. And that's my answer. So I'll do another example with you guys. This one's a little bit bigger. Rectangle length times width. So here I'm going to have x squared minus 1 times 3x squared plus 5x plus 4. So this is going to be a 2 by 3. So I'm going to draw a 2 by 3 rectangle and label. So x squared minus 1. We have 3x squared, 5x, and 4. This is going to give me 3x to the 4th, 5x to the 3rd, or sorry, to the 5th. Oh, nope, sorry, I thought that was an exponent. To the 3rd, I was right. 4x squared, this is going to give me negative 3x squared, negative 5x, and then minus 4. So I'm going to pull this out into standard form, starting with the 4th. So 3x to the 4th plus 5x to the 3rd. Then we have minus 3x squared. Then we have a positive 4x squared. Then a minus 5x. Then a minus 4. Okay. So then we look for like terms here, and that's it. Really, that's all we have. Oh, sorry, not here with the cubed, with the squareds. So we have just one set in the middle, the squareds. So this is going to become 3x to the 4th plus 5x cubed. Negative 3 plus 4 is a positive 1x squared. Remember, the exponents stay the same. Minus 5x minus 4. All right. So next one, we have another another triangle. So remember, it's 1/2 length times width, or length times height. So here, this is the height because it's that straight line up from the base to the top. So this is going to be 1/2 of negative x squared plus 6, 2x squared plus, and this is a little typo, this is going to be an x here, plus x minus 3. Plus x right here, so plus x here. So we're going to start off with the box method. Again, we're going to ignore the 1/2 until the end, just like at the top. We can only multiply two things at a time. So I'm going to create my box, 2 by 3. Negative x squared, positive 6. 2x squared, x minus 3. Negative 2x to the 4th, negative x cubed, positive 3x squared. 12x squared, 6x, minus 18. So I'm going to pull out into standard form, starting with that minus 2. So minus 2x to the 4th, minus x to the 3rd, plus 12x squared, plus 3x squared, plus 6x minus 18. And I should see that I have these like terms here, so I'm going to combine them. Negative 2x to the 4th minus x cubed comes down. 12 and 3 makes 15, so 15x squared plus 6x minus 18. Now, it's a triangle, so what we can't forget, 1/2. So now we're just going to distribute that 1/2. Now a trick, 1/2, when you have something, yes, you can keep doing the 1/2 times the number, but when we 1/2 or take half of something, we're dividing by 2. So think about it this way. What's 2 divided by 2? So negative 1 x to the 4th. Now this is going to be tricky when we're running into these odd numbers. So this is negative 1 divided by 2. That's negative 1/2 x to the 3rd. Same thing here. 15 divided by 2. We're taking half of 15. That's 7.5. So they're not always going to be pretty. 6 divided by 2, that's 3, so 3x. 18 divided by 2, minus 9. Okay. So the rest of these, what I want you guys to do is leave blank, and we're going to go over these because the area is a little bit harder, so we're going to go over the rest of these in class to start.